All right. I am recording. All right, cool. Okay, so let's get started. So this is going to be a tutorial on the C programming language. Like we're going to introduce a lot of basic concepts. So I think that might be a little bit, like a lot of stuff you guys already know. So we'll see and as we go. So a little bit about me. I'm currently a software development student at BlackBerry QNX on kernel development team. So what I do is, I develop the kernel. I help them unit test the kernel and things like that, different components. And on the side, I do a little bit of React and TypeScript developer. And I'm really crazy about object-oriented programming and all that stuff. So that's what you can find me doing in my free time. And now let's get started. So how does a C program compile? I think I talked to you yesterday about this, Gio. Like, can you tell me how does a C program compile?
So we can use the GCC compiler to compile the C code, and then so it goes like GCC followed by the file name.c. I kind of need to recall it, but yeah.
What are the 4 steps? What do you think? Like, that's more of an answer I'm trying to find, looking for. Like, what happens when you GCC something?
Okay, so GCC basically compiles it, and then it creates an a.out. That's an executable, maybe.
What is the first step of a compilation?
I'm not sure I have the answer to that one.
All right, Daniel, how about you? I talked to you about this as well. What is the first step?
So the first step is pre-processing.
Oh,
yes, sir. What's the next step?
Okay, we got. I definitely don't have a Google page open or anything. Second step is compiling.
Yep.
And then we have assembly, and then linking.
Yeah, that's right. So that's the 4th step in C program compilation. And so the main steps we're going to be caring about is pre-processing and compilation. Assembly and linking are important, but for your purposes in an operating course, you should care about them, but pre-processing and compilation are the most important when you write a C program. So what happens in in pre-processing, Daniel?
Right. So this is the first step, obviously, and well, let me look this up.
Right. So now don't worry about it. So I'll just tell you. So it expands like any macros you have, and any includes they paste all the content from the includes into just one single file. So that's essentially what an include does. So essentially you have, let's say you have include foo.h, and you inside foo.c, you take the content of foo.h and put it inside foo.c. That's all including does. So that's how you can see a pre-processing file. So gcc-e file.c -l file.pp, and now I'll show you that right now. So I have an example file here, and then let's delete that. And then I'll show you gcc-e example.c and -o example.pp. .pp just like pre-processing. So as you can see right here, it has a lot of includes, a lot of type defs, and because I'm including this standard in file, so that's why you're seeing all this stuff right here. So it contains all the standard int types. So literally just take everything and put it into one single file. Take all the content of these files and put it in here. And then you can, when you want to debug something, you can always, find something. So I'm using Vim here. Like you don't have to, you can just Control F on VS Code or whatever. But let's say I want to find the definition of int 64. So that's where 1 definition, 2 definition. Yep. And that's that. All right, let's go back. So that's how you can see the pre-processing file. So a define, you replace any occurrence of x with y. So what I mean by that is, like, let's say I have a define EOK over here. So anytime I see an EOK, I will replace it with 0. That's what a define does. That's what happens with define in the pre-processing step. Okay. And so and include, like I just said before, and then, include foo.c and include foo.c. Like this is the difference between using the double quotation mark and these guys. So include that means look in the pre-designated location. So these can be defined by your GCC compiler. Like, let's say you include standard in.h. So GCC will look for the pre-designated locations that comes with the GCC installation, and then it will grab the file from there.
And sorry, just a quick question. When you say locally, do you mean looking in the source folder?
Not, which one is that? Oh, this
So
one?
yeah.
The second line? Yeah, so looking locally means, looking around the source folder. If you include any -i flag when you compile a GCC program, that's what that is included as well. So that's counted as locally. And so, what is an include guard? Do you guys know?
Nope.
Nope, haven't heard of it.
So so if you look right here, right, right here, see how I have two standard int? How come that works? How come if I compile it, example .c -w, how come that still works? That's because of the include guard, all right? So essentially, this is it. So if not define foo.h, then define foo.h. So this is just a macro, right? So if it hasn't seen foo.h defined before, then define it, and then put all the content in. If it's seen it before, don't do anything. Just forget about it. That's pretty much how it works. And this is probably one of the favorite interview questions. These two are probably the favorite interview questions by any interviewer for a C programming position. You can also define functions. So this function right here is doing a round down. And I don't know if you guys understand this part. So A is going to be the number that we're interested in, and then B is the base of it. So let's say I want to round it to the base of 4096, which is 10 to the power of 2 to the 12. So what it does is it turns out B minus 1 will be turn on all the bits, right, of 4096, and then just round it down to like just end it. So that's pretty much what this function is doing. So this is just showing that you can also define functions. In the compilation part, you turn code into assembly level instruction. So I know you guys taken 2021 before. It's something similar to that. So on ARM machines, you turn it into RISC. On C, you turn it to like whatever it is, and then you can still read it. You can still read and understand it. This is how you see the compilation file, and I'll demonstrate that for you guys as well. GCC-s example.c-o example.s, and you can see like all this like CPU instructions right here. This is assembly. And let's continue. And then once we got past that stage, like you can't really understand it anymore because it's in machine code now and it's linking all the libraries and stuff. So we don't really care about that. So there are a couple of GCC options that are what I think you guys should know. So optimization level, what does that mean? Do you guys know?
Can't say I do.
Let's say I have, let's go back to this example. Let's say I have int a, and then right after that, what do you think will happen in this if I really optimize it? Is this assignment necessary?
You can just do a equals int a equals 2.
Yep. So that's what it means when you really optimize something. It's pretty much see any unnecessary path, and then it would just optimize it. Like it just bring this part over here, and then make it as optimized as possible.
So question about that: does it make any changes to the actual source code? I'm guessing it
Nope.
doesn't.
Mm-mm.
Okay.
So it just it does that when you compile it. So there are 4 optimization level. So -0, that's the lowest one. So no optimizing, whatever. Just whatever we have, compile it. And then -03 is the highest level. So sometimes if you want to debug something, compile it with 0, optimization level 0. And so you actually know what is going on. Another thing is -C. You guys know this already. It's compile no linking. -G, add debugging symbol. So this is what you use with GDB.
Mm.
-I, so that's what I mentioned before. Like if you want to include, let's say, another directory, so you do -I and then the path. -O, output files, you can rename it, whatever. By default, it's going to output to a.out. This one, you always want this one. Like you want the warnings. Like under no circumstances, do not ignore the warnings. Like I know a lot of people like in first year or second year, they usually say that, oh, it's only a warning, just forget about it, but please don't. Yeah, you want your code to work. Like warnings are there to help you, right? So let's go to the basics. So do you guys have any questions about these options at all?
Actually, just out of curiosity, like for the optimization level by default, if you don't specify a level, like what level is given?
I think it by default it does 2 or 3. I'm not too sure.
And that's a capital O for the optimization and a
Capital O, yeah.
lowercase. Okay.
Yep.
For the output, right?
So we'll talk about a little bit about the basics, like identifiers. What is this one? Unsigned and signed. Have you guys seen this before?
I think that the general idea is an unsigned variable can take on like a wider range of numbers. Unsigned simply means that it does not take, for example, negative numbers.
Yep.
Signed would.
How does that work though? Okay, Gio, I have a question for you. Do you remember anything from 2021?
I remember studying all this, but I really can't recall it right now.
Yeah. So, so the way they usually do it is that the first bit, like let's say you have a number.
Oh, okay, yes.
In binary, that's going to be a series of bits, right? So the first bit is usually the sign bit.
Yeah, the first bit is assigned.
So that's exactly that. Like if it's unsigned variable, then we know that the first bit is going to be actual number. And then if it's signed, then the first bit is going to be reserved for sign.
Yeah.
Static. All right. What is static? This is going to be an interview question as well.
In like the C context, or just
in the C context. You have static local variable and static global. What does static local do?
I think local simply means that the scope is set to local. So, for example, if you have a function, that variable is seen by that function only, and nothing external.
And Gio, do you agree with that?
I honestly don't know.
No, all right, yeah, that's fine. But
It's anyone's
no, that's
guess.
wrong. No, so a static local variable will reserve its value after calling. So what I mean by that is, let's say I have, let's use this one for now. Let's say I have another function called foo, that, and return I. Let's say I return I here, and local static int I is 0, return I plus plus. All right, and I want to print foo int a is foo, print a, and then a is foo again, printf. What do you think is gonna happen? What are we printing?
We're gonna start printing numbers. It's gonna print 0, and then if we run it again, it's gonna preserve the value. Like it's gonna increment it, and it's gonna print 1.
Yep.
And then 2, 3.
Yep. There you go. Yeah. So static local, it will preserve the value of I. That's very good. So when you have a static local variable, it will preserve the value of I on every call. And if you have a static global variable, it just means it's limiting the scope to that one file only. It's essentially a private. Not really. Like in Java, it's similar to using let's say private or protected. So it's limiting the scope of that function to that same file only.
So
like let's say if I have a static int I static int I j, yeah. So none of the other files can access this variable without including the same file. If I don't include main.c, I cannot take this thing. So basically, go ahead.
If we extend this file, like I forgot the term, like extern.
Extern.
Yeah. So if you use extern in another file to call this value, it's not gonna be able to access it, right?
So what extern does is just saying, okay. Wait, you mean, I get what you mean. So if I call extern on another file like this, I cannot access this one because this one's static.
Okay.
So that brings me to one of my future points, actually, extern. So that means the variable can be found somewhere else after the linking and assembly process. Like after we're done, then it can be found somewhere else. Not in the same file, but can be found somewhere else. Const, it's a constant that's self-explanatory. Extern, there you go. Register. Ooh, you guys haven't seen this before. What do you think it means?
Registers their blocks in the memory.
So traditionally, you know how CPU have registers and stuff, right? And these registers, they usually can be accessed faster than other variables. So if you declare a variable as a register, it means, hey, you can put this variable within one of these registers for faster access. Nowadays, they usually do this automatically. It doesn't matter anymore, but hey, that's what it means. It's just a hint to the compiler, pretty much. And size of variable, we'll come back to that later. Void, that's self-explanatory. I think you guys already know this. Type def, creating a data type. Have you seen this already, Gio?
I've seen it, but I haven't used it actually. Like during the labs and stuff, professor used to just give us some code as we went ahead, and I have seen this, but I really don't know what it means or how it works.
All right, I'll show you that one in a couple slides, but it essentially means it's creating a data type. Like, you know how you making a class in Java or something, right?
Okay.
And so it's like that, but not really, pretty much. It's just declaring this is going to be a type.
A type as in integer, double float, something like that, or?
Yeah, so you can declare a type ball or the type, coffee, things like that.
Okay.
Struct and union, this is pretty much making an object, quote unquote, not really. We'll come back to that later as well. Go to, what do you think this one means? This one pretty self-explanatory. How do you think it works?
It jumps to an address, or I should say, I'm thinking of, yeah, go ahead.
So it's pretty much like this, okay? If I have, I can declare a jump point like this. Out, and then if out, then return 1 instead. So it's let's go over here. I don't want to return, I want to go to out. If I run it, oh, because this is below that. It's pretty much what it is. Like, when you declare go to out, it jumps down here.
It's a good jump instruction in Risk.
Yep, it's pretty much that. So I don't know if you guys remember that from 2021. What else? Let's continue. We covered these. Object. So it's kind of similar to other languages. It's a region of data storage. So in memory, let's say you have an int I. So that region will be, I is going to be an object. And the region of that I contains is usually 4 bytes. So which bring me to the next concept, which is struct. So this is where you can see type def, Gio. So
Oh, okay, yes. Okay.
So this is pretty much you declaring that if you make a ball T object, you can expect a field radius and a field diameter.
Actually, I've used this. I just forgot about it, yeah.
Yeah, you must have, because like this is like really how you make a data structure.
Yeah.
In C. So Daniel, have you seen this before?
I have, but in a different context. I think in my situation, there was a large data type. It was an unsigned 64-bit integer, and I think we used type def for that.
Yeah. How about struct? Like you must have used it before.
I think,
right?
yeah, we definitely use struct.
Yeah. So essentially, you're gonna do it pretty much like in Java. You can call it by ball.radius, ball.diameter to access these fields. Declaration, definition, and initialization. Okay, this is gonna be a fun one. So this is more like an interview question, but it's good to know. Like, what's a declaration? What do you guys think a declaration is?
A data type and some name.
We're close. Like, what does it mean when I do like int foo? Is this declaration?
This is the function declaration. So foo is a function that takes in no parameters and returns with ints.
Yep. So that's declaration. So pretty much what happens is like every time you do this, that's a declaration, right?
Mhm.
So declaration memory will not be allocated. So got to keep that in mind. So definition, okay, what is the definition in this context?
I think it's the body of, well, in the case of a function, for example, foo, that would be the function definition.
Yep, so this is the definition of foo. So this is what foo does. So therefore it is defined. And as for initialization, well, I'm sure you guys already know what that means. Pretty much that it's A is initialized to whatever the return value of foo is. And so, yeah. So this trying to remember this because I think this is going to be a good interview questions. Or, like when you debug and you somehow figure out like, oh, it's not defined yet, but what the hell is going on? So that's what it means. Like you haven't defined the function yet, or you haven't initialized, haven't declared it. Next topic is types and operators. These pretty much self-explanatory. Like you just go online, look for them, and the more you use them, like I'm not going to go through them, but because like there's so many of them. But go online. As you work with them, you get more familiarized with them, and then so these are all the C operators. So these are the size that I was talking about. So when you call size of, if size of car would return 1, size of unsigned car 1. So that's how you can find the size of any of these variables. And they do matter, like the size. Memory management. So there are 3 main memory management method. The first one is malloc, calloc, and free. Like I'm sure you guys used this before. What's the difference between malloc and calloc? What do you think? And I think I definitely asked you this, Daniel.
Yeah, you did. So I think that the calloc function just it allocates space in memory with a particular size. These are different blocks of memory, and they're defined by some kind of, like I said, size. Could be an int, could be more than that. But I think malloc is just randomly selected areas of memory, usually assigned garbage values.
How about Gio? Do you want to take a shot at it?
Malloc, I think malloc just assigns some memory block, and then calloc it initializes that specific block to a value. I think by default it gives 0, but
Yep.
yeah.
Yep, that is right. Yeah, so malloc, don't initialize the values. Calloc, initialize the values to 0. That's pretty much what it is. And free, essentially, once you allocate the memory, you want to free it to prevent memory leak. And so, yeah, so free the program, so free it so the program can reclaim it. You want to use this one when the variable can be free after we're done. Like, as in, if you don't think you will use this variable anymore after, then just free it. It's once and done. Like, let's say you're using your calloc a variable, and then once you finish all your operation with it, just free it so you don't have to like worry about it after, and you free up some memory, improve performance, things like that. So this is pretty much all you're gonna touch in OS, I think, Geo. So every time you malloc, calloc, please remember to free it. Yeah, so like in the context of a course, it probably doesn't matter because you're probably not going to run out of memory, but you know, it's not a good thing for a memory leak to happen. Memset, I don't know if you guys seen this before.
We haven't been taught this in class, but I've like searched it up for a lab or something. Yeah.
So how about you, Daniel? Have you seen Memset before?
No, never.
So what Memset does is look at the content, look at the address of foo and the size of foo and change the content of that block to 0. So it's a good way to initialize a variable as well, besides calloc. So let's say you have a foo variable and you want to initialize everything to 0. You want to use memset. And you want to use this variable if, oh yeah, this point as well. So it does not alter whether memory is allocated or deallocated. So after you freeing a variable, it's deallocated, but the pointer is still pointing toward the same location. So with memset, that any memory location just change it to 0. It doesn't matter if it's allocated or deallocated. Just change it. And you want to use this if the variable will be used over and over again. So let's say in the context of unit test, which is what you're going to be doing, Daniel, you want to use memset because every time you reset a test, that variable is going to be used again, right?
Right.
And so you want to, you know, put everything back to 0.
Yeah.
Just to reinitialize it. And then after that, there's map, which is what you're going to be doing, Gio.
Okay, I haven't heard about this one.
Yeah, no, don't worry. Like they will teach you about it. Like I'll touch on it a little bit.
Okay.
But so it essentially map files into memory. So you see this FD thing? That's a file descriptor. So it comes with like the address, you know, where you want to map it. If you don't map it, you don't specify this, it will put whatever. Size, you know, protection flag. So you can see this on the man page, but you want to use this for larger things like files and stuff. So summary, use malloc calloc if the variable can be free after we're done. Memset if the variable will be used again, and mmap if for larger things like files and stuff.
I actually had a question. So you know how with arrays you like typically use like a for loop to set all the entries to 0. Could you use memset in the same context?
Wait, what would you?
So let's say like you want to pretty much initialize an array, and you know how if you create, you don't want to have garbage values, you want to have some kind of, you know, you want to have zeros, let's say. Can you use memset in that case too?
So how you would do that is, let's say if you want to do just for a variable. So what you can do is you can memset address of A to 0 and size of int. So that will just, you know, set the size of int for this guy to 0. But if you want to do an array, like 5 or whatever, right? So what you want to do, because you can't use the size of int because like it's an array, right? It's bigger than int. So what you want to do is size of A.
Right.
So it's this entire range. And that's how you're going to initialize the entire array to be 0. So this is for array. This is for a single variable. Pretty much it. Got it?
Yep.
All right. Let's see what's next. Pointers. All right, this is going to be a fun one as well. All right, how familiar are you guys with pointers on a scale of 1 to 10?
6 for me.
6? All right, Daniel.
I'd probably say about the same. Yeah.
I'm telling you, like once we go through the next 3 slides, it's gonna be like a 10. Like it's so easy.
Okay, let's do it.
All right, so this is the scenario I have, right? Foo is 0. So I have a foo variable, which value is 0. I have a pointer a, which points to the address of foo. And then I can do the value of a is 2, or I can do this. So what's the difference between these two, right? So I'll show you in the next slide. So star a means access the value of what being pointed at by a. Address of a is the address of the pointer, and a is the value of a pointer. So if you look down here, right? So let's say at address 0x1000, you have the variable foo, and the value is 2, right? When I do star a is address of foo, I'm saying that take a and set the value to the address of foo, like that. Okay. And so once you get this table inside your mind, like pointers, that will be it. So let's say a is 2. If I do this operation, what will happen? If I just a equals 2, what do you think will happen?
Or it just becomes 2 then. Changes from 0x1000 to 2.
It's
What will happen though? If I try to do star a again,
will have no value because A has a different address now.
uh,
I think it's the
well,
same address though.
yeah, a will still be at the same address. A will still be at 0x1004, but the value of a is now 2. What will happen if I do any operation with a, like star of a or whatever?
I think star of a just returns 2.
Are you sure about that? Because look at this, right? Access the value of what being pointed by a. So what is being pointed at by 2? Nothing, right? Because this means you're going to the memory address of 2. Okay, I'll show you guys here. All right, let's clear this out. Let's say I want to turn that off. In foo is 2, right? Int a is address of foo, and a is 2. Let's go debug. Start. What do you think will happen if I print star a?
It's not gonna print any value, or just a random. Okay.
See why? Because the memory address 2 is not valid one, because you can't do that. Sometimes it will work. It depends on like how you program your stuff, but once you set the value of a pointer to like a random value like this, it's usually going to result into that. So pretty much a pointer, the value is always going to be a memory address, right?
Mm.
So the value of pointer is a memory address. So what it means by star a is that, okay, look at what being pointed at by this memory address. And so if I do star a, I mean, okay, go look at what 0x2 is pointing at. But it's nothing because that's not a valid memory region. So you can't do that. So always keep this table in your mind when you work with pointers. Like after a while, you just get used to it. But so let's say I can do 0x. What do you think this will happen? Pretty much the same thing, because this address is not being allocated yet. You can't access it, right? And so star A, so always keep in mind, a normal variable, the value will be a, 1, 2, 3, 4, 5, 6, 7. A pointer variable, the value will be a memory address. If you want to star A, then go to that memory address, get me the value of what being pointed at by that memory address. So let's say if I bring back 0x1000, go to 0x1000 and get me the value in this case. So go to 0x1000, 0x1000, value is 2. Does that make sense? Or do you need further clarification?
I think it does.
Yeah.
Yeah, this is pretty much like all you need to know about pointer. So a value of a pointer is a memory address.
Mm-hmm.
Go to that memory address and tell me what the value is, which is star A. Address of A will get you the address, and then A will get you this guy. That's pretty much it. Like, it would take some time to get used to it, but that's pretty much everything you need to know about pointers. Also, you have pointers arithmetic. So A plus 1 will pretty much bring this guy to the next value. So you have A pointing toward 0x1000. And since A is 4 bytes, plus 1 is going to be 0x1004. That's pretty simple. Like, does that make sense?
Yeah.
So pointers on pointers. So this is going to be a fun one too. So what do you think happening here? So I'm declaring a variable B, and I'm pointing it at address of A.
Yeah.
So this is pretty much it. So I'm setting the value of B to be the memory address of A. See how that matches this guy? And so what do you think will happen if I do something funky? Like, let's say I declare a pointers on pointers, right? But I will just set it to A. What do you think will happen if I print B?
I don't think it's gonna work.
So if I print B right now, this is going to be the memory address of A, right?
Yeah.
What about if I print star B? What does that do? And what does star B do?
Access the value.
Of A, right?
Right, because they share the address.
Okay, what is... Yeah. What does star BB do? And why is that?
Doesn't exist.
No, because so here I have a pointer on pointer. I'm declaring B as a pointer on pointer, but I'm only assigning it to a pointer, right? So the type of A is a pointer, right? The type of B is a pointer to on pointer. You see how that mismatch?
Yeah. So we need an AND over there, right?
Yep. So if I do N, over here. That will work perfectly. And if I debug it, start, print, start B. There you go. Now I get 2. And I remember finding a really interesting thing about this, but I can't recreate it for the life of me. But I'm sure we'll come back to it eventually. But so that's pretty much that. Like, so if you have a B, go to that. This is all you need to know, actually. Access the value of what being pointed at by A. And if you add another star on top, that means it going to pointer on pointer. So what it means is that, hey, I have B. Let's go to the value of that, and then point, give me that. So that's what happens when you do star B. Okay, really simple stuff. Bitwise arithmetic. So you come across this a lot if you work with embedded systems or operating systems. So this is how you clear a bit. I don't know if you guys seen this already. Do you understand like what's going on here?
Yeah, I get it.
All right. So how about Daniel? Like, do you know how this works?
So I have a question about the ampersand equals. I'm guessing it's just the and bitwise and operation.
Mm-hmm. Yep.
But it's assigned, so it's like you're pretty much saying foo is equal to let's turn off all the bits, all bit 1, and
Yeah.
then assign to foo.
Yeah. So what do you think happens when if I do like 1?
Just increment foo by 1.
Yeah. So it's pretty much the same thing over here, as in, you know, so and foo with not of 1, and then assign that back to foo. And so an example of that, let's say foo is 0, 0, 0, 1, 0, 0, 1. And I want to turn off that, right? And so what's not of this?
Just everything is 1 except for the last digit.
Everything 1. And then what happens if I AND it?
Together.
Yep.
So you get 0, 0. Pretty much everywhere you see a 0 is going to be a 0, exception of that 1.
Yep.
Yeah.
So that's the operation underneath it. So that's what happens when you do this. When you do this, pretty much 0. Let's say this bit is off, and so you just OR it, right? Pretty simple. And then exclusive OR, also very simple. That, yeah.
Just a quick
Really.
question. So like on the right hand side of the assignment, you have 0x1. Can you just explain like how would you even read that? Like what does it exactly mean?
Oh, this is
like
just
how do you interpret it?
Oh, this is hexadecimal. So
that's what that is.
Yeah, so if I do 0xf, what is that?
F is 15. So it would just
Okay, tell me the bits.
Okay, there's 4 bits in hex, right? So it's gonna be 1 1 1 1.
Yep.
Yeah.
What is 0xf? F.
So both are 1s, like all 8 bits are 1?
Yep. So that's just, so every time you do 0x1, x means, hexadecimal.
Hexadecimal, so just like the last bit right there.
What is this?
Okay, so 0, last bit is 0.
Notice the B here.
The B, yeah. One sec. Where's the X though?
That's a good question. Where is the X? What do you think, Gio? Where's the X?
This is octal, right? Or
Okay, it's not octa.
no? Okay.
The B stands for
Binary,
something.
binary.
There you go.
Okay. Okay.
Okay.
What does that evaluate to?
All zeros for the first four, and then 1 0 at the last two digits. Like,
Yep.
yeah.
So that's binary. That's hex. I mean, there are more, but you can
It's a good
feel free to
refresher.
Google it. Yeah. So got to be really familiar with binary and hex and stuff once you start working with OS and embedded systems. Okay, this is clear, right? Like this is pretty easy. Got it?
Mm-hmm.
All right. Cool. My favorite part, GDB.
Yeah.
All right. I think Gio, you did say that they taught you GDB at school, right?
Mm-hmm.
So this is extremely helpful in any C programs. Like I cannot stress this enough. Like if you do C programming, you better know GDB. So you want to compile with the G flag.
She.
You can actually add optimization level with the G. So like dash G3 means compile with optimization level 3 or something. And then you want the text user interface, which is TUI.
Yeah.
And so there's some GDB commands, and I left like a link here, so I'll send you guys the presentation after. So there's a link here to all the commands, so feel free to go through it. But you know, this is just some basic stuff like P is for print, next line, step into a function, continue execution, breakpoint, delete breakpoint. F is for continue until completion of the function only, and Q is for quit. Like pretty easy. Like, what do you think? Like, have any questions about these at all?
No.
Yeah, it's like really simple stuff. So summary, C is really super duper simple. There's no fancy features, makes it unique. So if you ever get stuck, look at preprocessor files and utilize GDB. So if you look at preprocessor file, you know what's being included in your file. And if you use GDB, you can debug it. Linux man page is your best friend if you're taking OS or you work anything with OS. Like I cannot stress this enough. So man page, like you guys know how to open man page, right?
Mm-hmm.
Yeah.
So you can either Google it or you just man fd open and things like that, and then you get the thing. And a couple project ideas for you guys is make your own programming language in C. Make your own Linux shell. This is like really important for you though, Gio, because 100% the professor is going to put this as your first assignment. Like no doubt.
Okay.
Like I've seen it probably a dozen times now. Like this is always the first assignment. And there are plenty of examples online. Like you can look on Geeks for Geeks. And I know you're playing around with embedded systems as well. So this is a good way to play with C as well. So these are the three main project ideas that you can do to get familiar with C. I actually started making a programming language in C, but I kind of stopped. You can look at it on my GitHub profile. I've only made the parser so far. So essentially what it does is that, it's parsing a type, like whatever you want into a more readable language for the machine. So yeah, so you can feel free to follow any examples online, any tutorials for these guys first. Like I know you told me, Gio, that you don't know, like if they tell you to make something, you don't know where to start.
Yeah, because I haven't done enough practice. The first time I saw C was over here in this 2031 course, and yeah, but I kind
Yeah.
of found it really interesting, and I love it now.
Yeah. So highly recommend like going on a YouTube, look for any tutorials, play around with it first, you know, just to like know what these guys are doing, how they start, things like that. Once you're a little bit more familiar, that's when you can actually, you know, start project yourself. Like just
Yeah,
follow tutorials for now, and then after that you can do whatever you want. And yeah, I think that's it for the main part of the presentation. I'll give you guys an example after, and I'm going to turn off recording if I figure out how to do that.